Okay, so this is the next question. If z is a complex variable and z bar is the complex conjugate of z, that is or they are asking us what is the value? What is the value of limit z tending to 0 of z bar raised to the power of 2 divided by z squared? So we have got a list of values, so we need to choose which is the best fit. This is 0, 1, I, infinity, and limit does not exist. Okay, foremost, let me take z. Now, z as a representation in polar form as z is equal to r times e raised to the power of I theta. And z bar is going to be equal to r times e raised to the power of negative I theta. So, if I were to take z bar raised to the power of 2, then this is going to be r times e raised to the power of negative I theta. This entire thing is raised to the power of 2. You can rewrite this as r squared e raised to the power of negative 2 times I theta. This is what I got. Now let me consider z squared. This is going to be r times e raised to the power of I theta. This is raised to the power of 2. I square it. I get r squared e raised to the power of 2 times I theta. So therefore z bar squared divided by z squared is going to be equal to r squared e raised to the power of negative 2 I theta divided by r squared e raised to the power of 2 I theta. This has got a negative sign, this has got a positive sign. R squared goes off, so you have e raised to the power of negative 2 I theta over e raised to the power of 2 I theta. Now you can move this to the numerator. This is e raised to the power of negative 2 I theta multiplied with e raised to the power of negative 2 I theta. Now a raised to the power of n times a raised to the power of m is a raised to the power of n positive m. So by that we have this entire component to be rewritten as e raised to the power of negative 4 times I theta. Right, you can add these two things. So hence we are asked to find limit z tending to 0 of z bar squared over z squared. This is equal to limit. Now z tending to 0 of this quantity has been found to be as e raised to the power of negative 4 times I theta. Okay. Now what is the most important thing that you observe here? The quantity is independent of r. There is no r there. There is no r, just a theta. Now this means theta can take any value between negative pi and pi, right? So when the values can be varied, say for example along the real axis, if I take theta to be equal to 0, okay, this is along real axis, theta is equal to 0. So what would you get? You substitute it here, e raised to the power of negative 4 times I, theta is 0, you get 1. This is one value. Next, you take the imaginary axis. So let theta is equal to pi over 2. This is along the imaginary axis. So what do you get? E raised to the power of negative 4 times I pi over 2. So this is e raised to the power of negative 2 pi I. Right. But what is this? This is nothing but 1. Okay. Now let me just go up and take theta is equal to pi over 4. This is along the line. Okay. Now guess what happens? This is e raised to the power of negative 4 times pi. 4 times I of pi over 4. 4 gets cancelled. E raised to the power of negative pi I. Now what is e raised to the power of negative pi I? You get negative 1. You follow me? So the value changes. Value changes with what? what is in this context, what is exactly changing? What happens here? The direction. It changes with what? Direction. So there isn't any set value that we can look up to, because the quantity is depending on theta. So that would mean the limit does not exist. This is the correct choice. Okay.